We use the internet all the time, right? And it feels like pure magic. But what if I told you it's not magic at all? Today, we're going to pull back the curtain using a really simple analogy, a post office.
Yeah, this quote really nails it, doesn't it? Behind that smooth, seamless experience of browsing the web, there's a very real, physical world of cables and servers all following a strict set of rules. It's less magic and way more like a super efficient global delivery system.
Okay, so to really get our heads around this, let's try something. Imagine, just for a few minutes, that you and I are postal workers, and our one job is to follow a single piece of digital mail from the moment it's sent to the moment it arrives. This journey is going to explain everything.
So, where does our job begin? Well, it starts at a place you know very well, your keyboard. This is where the whole process kicks off, where our digital letter gets created.
Think about it. Every single time you type in a web address, like say google.com, you're basically doing the first step of our job. You're writing a name on an envelope, telling the postal system exactly where you want your letter to go.
But here's the thing. A name alone, that's not going to cut it for our high-tech postal system. Our sorting machines need something way more specific to find the destination.
So picture this. As a postal worker, I'm looking at this envelope and I see google.com. That makes sense to me, a human. But the sorting machines, they don't speak English. They need a number, a specific machine-readable code to get this thing where it needs to go.
And this is exactly what that translation looks like. On the left, you've got the name we all recognize. And on the right, you've got its IP address. We humans, we're great with names, but terrible with long strings of numbers, right? Computers are the total opposite. They love these numerical addresses.
So the big question is, how does this translation happen? Well, it's all thanks to something called DNS, the Domain Name Service. The best way to think about it? It's literally the master phone book for the entire internet. It looks up the name you give it and finds the correct number.
Okay, so we've got the right machine-readable address, we know where the letter is going, but hold on. Before we just send it off, our postal service has two super important steps we have to follow to make sure everything is safe and secure.
First things first, security. I mean, you wouldn't send your bank details on a postcard for the whole world to see, would you? Of course not. So our job as the postal worker is to take that letter and seal it in a special, tamper-proof envelope that scrambles the contents. That way, even if someone intercepts it, they can't read a thing.
This right here is the crucial job of SSL, or Secure Sockets Layer. It's what provides that encryption. And you see this in action every single day. You know that little padlock icon you see in your browser's address bar? That's SSL telling you, hey, this conversation is private, we're good to go.
Okay, security is handled. Step 2 is all about confirmation. We can't just throw this important letter into the void and hope it gets there. Our job as the postal worker is to call ahead, essentially, and make sure the destination post office is actually open and ready for our delivery. And this confirmation, it's like a quick, polite, 3-part conversation. First, our post office sends a signal that says, hey, I'd like to send you something. That's the SYN. The other side replies, sounds good, I'm ready for it. That's the SYN-ACK. And finally, we reply, great, it's on its way. That's the ECK.
So this polite little back and forth, this postal confirmation, has a technical name. It's called the TCP handshake, and it's absolutely fundamental. It's how two computers agree to have a stable, reliable chat before any real data gets exchanged.
All right, let's check our list. Address? Check. Secure connection? Double check. Now, finally, it's time for the main event, the actual delivery. So our super secure letter finally arrives. And what's inside? It's basically a note that says, hey, could you please send me the files for your homepage? The server gets it, and boom, it starts packing a box with everything you need, all the text, the images, the code, and sends that package right back to you.
Now, this whole conversation, the way the request is written and how the package is sent back, it all follows a specific set of rules, a common language. That language is HTTP, or Hypertext Transfer Protocol. It's what lets browsers and servers understand each other perfectly.
But here's a really cool detail. That big package of website data, it doesn't get sent as one massive file. That would be super slow. Instead, the system is smart. It breaks it all down into these tiny, numbered chunks called packets. It's kind of like shipping a giant Lego castle in hundreds of little numbered bags. Your browser gets all the bags and then puts them together in the right order to build a final web page.
Okay, so that whole process is perfect for loading a web page from scratch. But what about all the little things you do on a modern website, like when you just click a like button on a video? You're not asking for a whole new page, so how does that work?
I mean, it would be crazy inefficient to request a whole new website package just to register a single WEC, right? So our modern post office has a solution, a special department, a specialized mailroom, just for these super fast, tiny requests.
And this special mailroom, that's what we call an API, or Application Programming Interface. It's what lets an app on your phone ask a server for one tiny piece of information, like the current temperature, without having to reload anything. It's the secret sauce that makes modern web apps feel so snappy and responsive.
All right, so let's put it all together one last time. In our post office, the name on the letter is the URL. The master address directory we use to find the right code, that's DNS. The secure, tamper-proof envelope is our SSL encryption. The polite three-step confirmation call is the TCP handshake. The letter and package exchange is the HTTP request and response. And that super-fast specialized mailroom is the API.
So when you really pull back the curtain, the internet isn't magic at all, is it? It's this incredible physical system built on a foundation of really clever rules and protocols. And it kind of makes you think, right? What other magic we take for granted every day is really just some brilliant engineering hiding in plain sight.